Hello, I am Pratik Kumar and this is Neuronics Lab IISc. My primary research focuses on conceptualizing, building and prototyping the first of its kind technology, energy and performance scalable analog processor. The goal is to build India's first indigenously developed fully analog processor for AI, ML and edge applications. We started from a novel concept and then focused on a very fundamental problem that we decided to solve. The challenge was to design a reconfigurable analog system that is simultaneously technology scalable, energy scalable and performance scalable. This was a major shortcoming in designing any high performance analog compute system. Once we solved this issue, the goal was to target a real world problem. We conceptualized everything, starting from the novel mathematical formulation to the transistor level design and then up to the system level product design and test. What you are seeing on the screen is a multi-core fully analog architecture. It's a custom design built from the transistor level up to the system level. This initial prototype of this novel AI chip contains 8 high-performance computational cores, which we are planning to extend in the future releases. The current version of this AI chip incorporates multiple features such as the architecture is fully reconfigurable and programmable. The design itself is technology scalable, which means that it can be ported from one technology node to another without losing its functionality. The architecture also offers the end user flexibility to select the energy and performance parameter as per the desired application. Chip designing was one part of the problem that we solved. Apart from this, we developed a custom compiler for the chip from the scratch. The current version of the compiler takes one or more machine learning algorithms along with user-defined parameters such as operational performance mode, energy mode and other specifications and translate them into bits for programming the chip. Another major challenge was to test this massive chip. This is especially very time consuming task and is impossible to do manually when your chip has millions of transistors. At the academic level, with limited resources that we have, it's a massive challenge to undertake. To overcome this, we designed a one-stop automated testing framework specifically for AI and ML tasks for academic use. We designed a framework that can interface high-precision test equipment with ping board and then to a common test chip. It uses Python for communication and provide interface to any computer. The overall framework works like this. You write the test code for your chip. No matter how simple or complex your test code is, it can be as small as writing a Boolean test or as massive as testing billions of computational points that can take months. So you write it in high-level language Python and execute it. Our test framework takes care of the rest. It keeps on executing and storing your result in the desired format at the location of your choice, and all of this happens using a common language Python. We sorted out all these issues and started testing the chip. We are glad to share that the results are very promising. For instance, what you are seeing on the screen is the response of the chip computational cores to nanoamp variation in current. The steps are responses of the modular die. Depending on the applications, the chip can operate from hundreds of microwatt in energy efficient mode to few milliwatt of power in high performance mode. In a nutshell, the research highlights are as follows. We designed the AI processor from transistor level to the system level. We then designed a compiler from scratch up that takes machine learning algorithms and port it into processor for real-time tasks. To test the chip, we further designed one-stop automation framework that can interface test equipment, FPGAs and others using a common language Python and automates the testing. All these are indigenously developed and we are looking forward to make many more such advances in the upcoming versions.